Hello and welcome to lesson 13 of module 1. This is going to be our last lesson for this module. We're going to go through some word problems, solving and computing in scientific notation. Let's go ahead and get started. Alright, just to review our rules, when we are multiplying in scientific notation, we multiply the numbers and we add our exponents just like so. You'll see that they have multiplied A and C together and they have added B and D together, which represent those numbers and exponents. When we divide in scientific notation, we divide our numbers and we subtract our exponents. So here we would divide whatever A and C would be, and we would subtract the B and the D. And then when we add and subtract in scientific notation, the first thing we have to do is make sure our numbers have the same exponent. You'll see right here they don't. Here they do. They just moved it one space to make them both 3. And then they had to move their number back one space, make it one space smaller. And then you just add your numbers up and you keep the exponent that you changed it to. Okay, let's go ahead and get into some practice. Exercise 1 says the Fornax dwarf galaxy is 4.6 times 10 to the 5th light years away from Earth, while Andromeda is 2.430 times 10 to the 6th light years away from Earth. Which one is closer? So what I want you to do is look at these two numbers and figure out which one of these is a smaller number. So which one is closer to Earth? So we're looking for the smaller number here. And we're going to compare these two. Now, there's a few ways you can do it. If you want to, you can actually write these numbers out. So this is 4.6 times 10 to the 5th. So this would be, we would move that decimal 1, 2, 3, 4, 5. Okay. And then this one over here is 10 to the 6th, so we would have our 2, and we move this 1, 2, 3, 4, 5, 6. And then you can easily see that that second number is bigger. It has 1 extra space. But we really didn't even need to do that because you can see that our exponent is 1 bigger over here, so that's going to be bigger no matter what. So even though 4.6 is bigger than 2.43, we're not looking at that. We're looking at our exponents here. And that tells us very quickly which one is the smaller number or the bigger number, which one's closer or further away. So which one is closer to the Earth? This one right here, the Fornax dwarf galaxy is closer. And we know that because 10 to the 5th is less than 10 to the 6th. Alright, let's go ahead and move on to the next exercise. Alright, it says the average lifetime of the tau lepton is 2.906 times 10 to the negative 13 seconds. Very small number. And the average lifetime of the neutral pion is 8.4 times 10 to the negative 17 seconds. Explain which subatomic particle has a longer average lifetime. So we're looking for the larger number or the bigger number. Okay. And like I said before, we really don't need to look at these numbers. We don't need to look at our decimals unless we have the same exponent. If we have different exponents, that's all we need to know is which one of these numbers, in this case we're looking for the bigger one, is bigger, negative 17 or negative 13. Well, when dealing with negatives, the one that is actually closer to 0 is bigger. So negative 13 is bigger in this case. That means that this has a longer average lifetime. This is called the tau lepton. And our reasoning is just right here, because negative 17 is less than negative 13. So negative 13 is going to be longer. It's going to be a bigger number. All right. Go ahead and make sure you have that down. Let's move on. All right. This one is just straight up asking you to compare these two numbers. We have 9.3 times 10 to the 28th and 9.2879 times 10 to the 28th. Well, in this case, you'll notice that they have the same exponent, so we can't rely on that. So if we have the same exponent, then we look at the decimal and we see which one is bigger, which one's smaller. 9.3 is bigger than 9.2. Okay, 3 is bigger than 2. And so if we were to compare these two numbers, we would write it like so. 9.3 times 10 to the 28th is bigger or greater than 9.2879 times 10 to the 28th. Okay, when it's asking you to compare, it just wants you to use that little greater than or less than sign. Okay, make sure you have it down, and then let's move on. Exercise 5, it says, Chris said that 5.3 times 10 to the 41st power is less than 5.301 times 10 to the 41st power because 5.3 has fewer digits. Show that even though his answer is correct, his reasoning is flawed. Show him an example to illustrate that his reasoning would result in an incorrect answer. So, they have the same exponent, right? They're both to the 41st power. And he's saying, well, 5.3 is less than 5.301. So one thing I want to help you guys be able to explain is why he's wrong. So this first number, 5.3, if I were to just add 2 more decimals, it would be 5.300. Okay? This one right here is 5.301. Well, what's bigger, 300 or 301? 301 is bigger. So this is an example of why you could explain how he's wrong. So Chris is wrong because .301 times 10 to the 41st power has a 1, where 5.3 times 10 to the 41st power has a 0, and 0 is less than 1. Okay, just a quick little explanation showing why he would be wrong. His reasoning, had a good point. He said, well, it's fewer digits, so it's smaller. But that is not true. It's smaller because the digits are actually smaller. Okay? Let's go ahead and move on to the next one. Alright, it says you've been asked to determine the exact number of Google searches that are made each year. The only information you're provided is that there are 35,939,938,877 searches each week. Assuming the exact number of searches are performed each week for the 52 weeks in a year, how many will have been performed in 1 year? Your calculator does not display enough digits to get an exact answer, so you have to break this number down and do it yourself. Okay? So basically it's saying this number, that's how many searches there are each week. There's 52 weeks in a year. Multiply those together. Tell me how many are done in a full year. So the first thing we have to do is write this number in scientific notation. So please pause this video and do that on your own, and then press play once you have it written down. Alright, you should have paused the video, written it down, and then press play, and you would have got this answer that I have here, 3.5939938877 times 10 to the 10th power, and we are multiplying this by 52. Okay? Now one thing I want to do when I want to multiply a number that is written in scientific notation with another number, I want to make this other number in scientific notation too. So this is the same as 5.2 times 10 to the first. So now I can multiply these. Numbers using how I know how to multiply numbers in scientific notation, the first thing you do is you multiply your numbers together. So I'm going to do that on my calculator. And you're probably not going to be able to write that long number all the way in your calculator, so you'll round off eventually. 3.59393877. Yeah, I can't even fit the sevens. And we're timesing that by 5.2. I get 18.6887682. Okay, and then from there, we're adding the exponents. So this is going to be times 10 to the 11th power. Our last step is to make sure this is correctly written in scientific notation. It is not, because this leading digit is too big. So I'm going to move it one space back. And if I make this number one space smaller, I make this one exponent bigger. Okay? So my final answer is how many likes are made in a year, or sorry, Google searches are made in a year. This is my answer. And I'm not going to write that number out completely. If you wanted to, you could. You just move this decimal 12 spaces to the right, and you would get your actual number. Okay? Make sure you have it down before we move forward. All right, just to review our background knowledge real quick. When we're multiplying numbers in scientific notation, multiply the numbers, add the exponents. When we divide the numbers, subtract the exponents. And when we add and subtract, once we have the same exponent, we just add or subtract and keep the exponent. Okay? Make sure to reference these drawings and these diagrams if you need any help. All right, your exit ticket today is posted in Galileo. Please make sure you get it done. Use your video to help you. Use your notes to help you. And then make sure you get your lesson reflection done once you finish this. Okay? And we are done with Module 1. We'll be taking a test pretty soon.